Hello friends, welcome to Shiksharthi. In this video, we shall be discussing arithmetic series. So let's start. Now if you have gone through my earlier video on arithmetic series, we had basically talked about the introduction, how is an arithmetic series formed. Now in this video, we will be focusing on some characteristic properties of an arithmetic series, including how to find out the sum of an arithmetic series. Okay. Now, let's say the arithmetic series that I am assuming here is T1, T2, T3 and so on till Tn. This is the arithmetic series that I have taken here. Now, what is T1, T2, T3? You must be aware of the fact as you have already gone through the first video. If you haven't, this gives you a chance to go through the first video because this is connected with it. So, the first term of an arithmetic series, second term, third term and the nth term of an arithmetic series. Now, for a better understanding, we will give it some values. So, for example, the arithmetic series that we are going to take now is, let's say a series like 2, 5, 8, 11, 14, 17. This is the arithmetic series that I have taken. So, the first property that I can talk about here is the common difference. So, can I say 5 minus 2 is equal to 8 minus 5 is equal to 11 minus 8, which is just like saying this is equal to the nth term minus the n minus 1th term, which is equal to the common difference. To put it into the right perspective now, so can I say the first property here is T2 minus T1 is the same as T3 minus T2 is the same as the nth term, which is the last term, and the last but one term, and this is equal to the common difference. Now the second property which comes from here itself, so let us say I choose I choose only the first two expressions. That means what I'm trying to say here is T2 minus T1 is equal to T3 minus T2. So what do I get from here? I get T2 is equal to T1 plus T3 by 2. Right? If I would have chosen the other terms from there, I'll get what? So let's say if I would have chosen the second expression and the third expression, I should have got T3 is equal to the term which is prior to this, which is T2, and then the term which is next to it, which is T4 divided by 2. Analogously, now I can say, now the n minus 1th term, that means the term just before this will be the term before this and the term just before this and the term just after this, which is just like saying n minus 2th term plus the nth term divided by 2. So now what is this? This you can say that the second term is the arithmetic mean of the immediate terms. Now the moment I use the word immediate does not have any direction. So it could be before and it could be just after. Just before and just after is the terminology for immediate. So can I say that this is my first arithmetic mean? AM is arithmetic mean. Arithmetic mean is when you are taking both the terms in the ratio 1:1. 1:1. So you take their sum and then you divide it by 2. Similarly, T3 becomes what? My second arithmetic mean. So can I say that now this became my first arithmetic mean, this is my second arithmetic mean, should I say? So this is the first, this is the second. In that case, this becomes the n minus 2th arithmetic mean. So if I have an arithmetic series, of n terms, how many arithmetic means will I have between them? N minus 2 arithmetic means is what you're going to have. So this is the second major discussion. Okay. third point, which is equally important. Now, if I want to locate a particular term, mark the words being used. If I want to locate the third term, how will I locate it? I'll locate it with the help of the formula. I mean, what I mean to say here is, you will say, what is the mean of location? You can always identify the third term, and you can say you already know that a particular term, let's say Tn. So we already know this formula, that Tn is equal to T1, which is the first term, plus n minus 1 into d, or a plus n minus 1 into d, n minus 1 into d, is that you already know. So what do you mean by locating? Locating here means, if I say that, let's talk about 8, which term is it from the left hand side? So locating a term in a given arithmetic series. So if you are just seeing this, and if I say this is 8, which is the third term from your left hand side, so this third term from the left hand side, which will be which term from the right hand side of yours? So for that, you just need to know the total number of terms. So here, let me count the total number of terms: 1, 2, 3, 4, 5, 6. So how many terms do I have? 6 terms. So a term which is third from this side will be fourth from the other side. So meaning thereby, now let us say that there is a particular term, let's say T3. This is third from one side. Now this one side could be left hand side or the right hand side. And I know that the total number of terms, are how many terms? Let's say n terms. The total number of terms are n terms. So from the other hand side, this will be what? So can I say n minus 3 plus 1? Which is just like saying what? N minus 2th term from the other side. To be more specific here, if there is a particular term, let's say TR, rth from one side, and if we have n number of terms in that arithmetic series, the same term would be n minus r plus 1 from the other side. Is this correct? Let's just check it out. I mean, there's no rocket science behind this. Let's just check it out. So let's say if I say this is the third, so let's say I already have the count of the terms. It is always good to take a finite series. Now what is a finite series? The finite series is a series, in this case we are talking about arithmetic series, which has countable number of terms. I mean, you can count all the terms, that there are n terms, there are 5 terms, there are 6 terms. And what is an infinite series? An infinite series is, you know that the last term has not been given to you. So that means you can't complete the count. Which is why, since you are unable to complete or ascertain the count, you say that the series is infinite. So finite series is wherein you can count the number of terms in that given series, and an infinite series is a series wherein you just cannot count the number of terms because the last term is not given to you in that series. Okay, so now let's say 1, 2, 3, 4, 5, 6 terms we had here. So we have, this is a finite series because the last term is given here in the series. Similarly, can I call this as a finite series? Yes, the first term is T1 and the last term here is Tn. Okay, fair enough. Now, once I know that it has 6 and I want to locate the third term. So the third term I have already located. Now, this is locate. It does not say identify the term. Identify here means which term is it. So which term is it is the third term. So let's say 8. If they ask you which term is the 8th, I mean there is a series which has a term as 8 in it. The value of a term is 8. Which term is it that you can find out? So that is the third term here. Now this term located, locate means now specify the coordinates. Now you can't, this is not a question on coordinate geometry. So you will say what? The location of this term is what? This is third from the left hand side, let's say the left hand side, and this is fourth from the right hand side. So now let me substitute the value of r here. R becomes how much? 3. What is the value of n here? 6. So 6 minus 3 is 3. 3 plus 1 is 4 is what we were discussing. So please remember this. The best way to remember this is what? So let's say it had 6 terms and there is a term which is second from the left hand side, or there is a term which is second from one of the sides, so which is 2. Add 1 to the total number of terms, which becomes 7 now. So from the other hand side it will be 7 minus 2, which is 5. Okay, I hope you have understood this. Point number 4. Now point number 4 here is, can I say so we already know how to identify the term, we know how to find out which term is it with the help of the formula. Now the location of the term also has been discussed with you. You know the concept of arithmetic means also. The next thing which becomes important here is to find out the sum for first n terms. So when I am finding out the sum for first n terms, can I say this will be nothing but t1 plus t2 and so on till n minus 1? This is how we will be finding out the sum for first n terms. Okay, now when we find out the sum for first n terms, you will say, so the first term can be written as a, the second term becomes a plus d, the third term becomes a plus 2d, and so on. You know that the last term is a plus n minus 1 into d. You already know, and you can just substitute the values to find out which term. As we are talking about, identify the term or find out the numeric value of the term. Now when I am adding all of these, you will come across something very interesting. So that interesting part I will discuss first, and then I come down to this. What is the interesting part here? Now if I take this series, which it becomes easier to identify with the help of the series. So the first term and the sixth term, when I add it together, so it comes from here only. So the first term and the sixth term which gets added from here is 19. So I can say 2 plus 17 is a 19, 5 plus 14 is a 19, 8 plus 11 is a 19. So can I say in an arithmetic series, the first term and the last term is equal to the second term and the second last term, and so on and so forth, if I am identifying one term from one side using the same logic that I have used. So let's say the rth term from one side, so the other term that will be taking from the other side will be what? N minus r plus 1, as already discussed. So let's say the first term from this side, the second term from this side. So when I substitute the value of r as 1, in that case what am I getting? N minus 1 plus 1, which is the nth term from the other side only. When I substitute the value of r as 2, so from the other hand side I will be taking the second last term. First term from this side, first term from the other side, second term from this side, second term from the other side. So you are basically taking symmetric terms from both the sides. So this is a case of symmetric terms. So if tr is a term from one side, so let's say this is the rth. So you will say this is the rth term from the other hand side. Hope you have understood this. We are using the same logic. We are using whatever we have discussed here as point number 5. Now, once I know this, I can play with this. Let's say this is point number 1. Point number 2, can I say t1 plus tn divided by 2 is just like you are finding out the arithmetic mean. So let's say if I want to find out the arithmetic mean of this series, of this entire series, is what we are doing now. Okay, so now t1 plus tn should be written as t2 plus t of n minus 2 divided by 2, and so on and so forth, as we discussed. This is just like you are finding out the arithmetic mean, AM, arithmetic mean. So when you are finding out the arithmetic mean of a given series, arithmetic series, you can just do what? You can just take the symmetric terms, add them and divide them by 2 to get the arithmetic mean of the series. Now once you have the arithmetic mean of the series, so can I use any of these here? Yes, you can. So this is now, since you know that the first term and the last term taken together is just like saying t1 plus t2. I'm sorry, t1 plus tn. And the same thing now you'll say for other terms. I mean, here you would say this is nothing but you take this from here and the second last term from there. How many such pairs would you make? Because you're choosing pairs. For example, 1, 2, 3, 4, 5, 6. You're choosing. So you're choosing 2 out of 6. So how many such pairs would you make? 6 divided by 2. Now when you are having n terms, how many such pairs would you have? N by 2. So from here you get the formula. What? The formula here is the sum of n terms of a finite series. Why do I call this as a finite series? We call this as a finite series because the last term is known to you, and the last term known to you here is Tn. Is nothing but the first term and the last term added together multiplied by n divided by 2. Or you can use another formula which comes from here only, which is just like saying you are adding a how many times and you are adding d how many times, and then you convert it into multiplication. So if I add a, how many times a has been represented here? It comes in all the terms. So you will say that a has been represented n times, which is just like saying a into n. And how many times has d been represented here? D has been represented n minus 1 times. Or you just open out the formula and you know that t1 is nothing but a and tn is nothing but a plus n minus 1 into d. From here, if you just open out the formula, you can make a fresh formula which is 2a plus n minus 1 into d. This entire thing multiplied by n by 2. This is another way to put this. Hope you would have understood this. Okay. Next thing which needs to be discussed is nothing but the application of whatever we have discussed till now. Now, what have we discussed till now? Just the application of that. For example, if somebody says, if you just recollect the type of series that we had taken in our first video. So, for example, if somebody gives me a series like 1 plus 1 plus 1 plus 1 and says, and the last term also here is 1, and how many such terms have you taken? Let's say you have taken n terms. So what are we saying? This is nothing but of the sort wherein a is equal to 1 and the common difference here is 0. In this case, when you are adding 1 how many times? N times. You can simply use this formula and you can say 1 plus 1 is what? 2. 2 into n divided by 2 is nothing but n. So what is the sum for this? The sum is n. This you can take it as a standard formula or you can take it as a lemma. Similarly, when somebody gives me a series of first n natural numbers, where capital N is my last natural number that I would have taken. So can I say here the value of a here is 1 and the common difference here is 1, which is nothing but you are forming an arithmetic series which is non-negative. No, it doesn't have a 0. It is a positive integer series, which is nothing but the natural number series, wherein a is also positive and d is also as positive, and a is not only positive but it is taking only integer values. Now in this case, how to use this formula? You can simply use first term and the last term. So can I say the sum for first n terms here would be first term plus the last term, which is 1 plus n. How many terms do you have in total? N divided by 2. This is nothing but I am just taking this as an application of this. Okay, point number 7. Now if somebody, instead of saying point number 7, it will be better if I take it as point number 3 only. So let's say point number 3, I am taking an arithmetic series like, let's say 2 plus 4 plus 6. So this is just like saying I am taking first n even numbers. Now when I am taking first n even numbers, I know that how can I find out the nth term for an even number? The first even number is 2, 2 plus n minus 1 and the common difference would be 2. So we will be saying 2 plus n minus 2, which is 2n. So the last term that will be, so this falls under the same category. Which category? A is positive and D is positive. And not only positive, they are taking integer values only. So applying the same formula, I can say sum of first n even numbers. Now this 2n is indicative of you are finding out the sum for first n even numbers. First n even numbers is what this 2n denotes. I'm sorry. So now in this case, you will say first term and the last term, which is 2 plus 2n. And how many even numbers have you taken? You have taken first n even numbers. So this formula changes to n into n plus 1. Last but not the least here would be if I take first n odd numbers, and using the same logic, if I want to find out the nth odd number here, which will be 2n minus 1. So I can say what? 1 plus 2n minus 2 is just like saying 2n minus 1. So if I want to find out the sum for first n odd numbers, so first term and the last term into n by 2, which is just like saying n square. Now these are certain things which should either be at your fingertips, or even if you would have forgotten, but you know the basics and the concepts which we have discussed, so you'll be able to establish all of them. Right? I hope you would have, or you will learn something out of this video. If you feel that this video is really informative and it takes your learning to the next level, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do some videos on specific topics, don't hesitate, put it in the comment section. Thank you so much. Until next we meet, goodbye.